Hey, it's Mrs. Golding, and I just wanted to run through some problems on this week's Friday paper 21, week 21, with you. Um, this Friday paper only has 7 numbered questions, but it really has 25 points. So question number 1, for instance, has a possible 6 points. So I want to make sure that we hit this one. It's pretty big. So when you look at this, it gives you the opportunity to show what you know about a lot of things. So the first thing is pi, that symbol pi. And we know that pi is kind of a measure of the ratio when you're talking about diameter of a circle. And so we use that a lot of times when we're talking about circumference and volume and area of circles. But it's also just an approximation that we can use when we're talking in math terms. So if we're unfamiliar with pi, I'm going to suggest that you use the Desmos calculator that's embedded in your computer. And when you pull up a new tab on yours, you get different icons here than I do. But I am going to go to the Desmos scientific calculator for you. That's the one that you can pull up on your home page. It's green and it says Desmos calculator 7th and 8th grade. It's basically the same as this. So I encourage you on this Friday paper to use a calculator. I'm going to hit the pi button here, and it gives me this truncated version of pi. Truncated means the calculator isn't going to give you the whole thing, but it'll give you part of it. And this ends with 3.141592654. And so, as you know, pi is an irrational number that goes on forever and ever and never repeats. So I'm going to kind of look at this, and then I'm going to go back to my my question, and I'm wondering if I could probably just use the number 3 for pi. Actually, I'm going to change that just a little bit, and I'm going to use my squiggly line here. That means it's approximately equal to 3. So what is 3 times -3? Well, that's -9, right? And so if we use that as an approximation, -9 and -8, we're comparing, right? Well, -9 is further to the left of -8.256 on the number line, so it is less than, okay? So let's talk about 4 2/3 as it relates to the 4 6/10. Now, when I said that out loud, I said 4 6/10. Notice I just wrote that as a fraction, right? 4 2/3, and then if I were to try to get this to be a 10 here, we know it's not equal because 3 is not a factor of 10. So we know we're kind of ruling out the idea that those are equal. But let's kind of think about 2/3. Is that going to be, as a decimal, a repeater? We know that anything that comes out over a 9 is a repeater. So times 3 times 3, 6. So instead of out of 10, it's 6/9. So 4 6/9. If we were writing that as a decimal, it would be 4.6 repeating. And that's 4.6666666666666, right? That makes it just slightly larger than 4.6, or 4 6/10. Or 6 pieces out of 9 is slightly larger than 6 out of 10. Each of those pieces is going to be a little bit bigger. Okay, the square root of 56 and 8 is what we're comparing. So the square root of 56 is not a perfect square, but it does lie between two perfect squares. I can think of 64 here and 49. So the square root of 49 is 7, and the square root of 64 is 8. In other words, 7 times 7 is 49, and 8 times 8 is 64. Now, which of these is it closer to? So I'm just going to count 49, 50, 51, 52, 53, 54, 55, 56. It's 7 away. And here, 56, 57, 58, 59, 60, 61, 62, 63, that's 8 away from 64. So it's slightly closer to 7. So it would probably be 7 point something, but maybe more like 7.4-ish. So let's go back to your calculator, and just to kind of be sure, and again, I'm encouraging you to use your calculator on this Friday paper. Great. So our estimate was pretty good. The square root of 56 is actually 7.4833147774. Remember, this is truncated. It keeps going, but it's going to go on and on. It's an irrational number because it's a square root of it's not a perfect square. So 7 is about 7.48. And that is less than 8, right? Okay, so now we have 2 times the square root of 9, or 2 root 9, and then we have the square root of 36. So 2 times the square root of 9, well, the square root of 9 is 3, so 2 times 3 is 6. And what is the square root of 36? It is 6. So these two expressions are equivalent. Okay, square root of 8 is not perfect, but it's really close to the square root of 9, and the one on the other side is the square root of 4, right? The square root of 4 is 2, and the square root of 9 is 3. Is it closer to 2 or closer to 3? It's really close to 3, right? So maybe like 2.8 or 2.9. So let's just check it out. Let's see what is. By the way, you can hit this enter key and see more than one thing at a time. Square root of 8, 2.828, and so forth. So we're going to go here. We're going to say this is about 2.8. And we're comparing that to this. Well, this is the square root of 16 divided by 2. We're going to take this vinculum as a grouping symbol, meaning we're going to evaluate the numerator first. What is the square root of 16? That is 4. Divided by 2 is equal to 2, right? So we're comparing something that's approximately 2 8/10 to 2. This is larger, okay? Now, we have two decimals, 0.3278, or 300, that's in a 10,000ths place. That's always hard for me to say out loud. 3,278 10,000ths. I don't think that's even right. But this is 325 tenths, hundredths, thousandths. Now, we're going to compare tenths place is the same, hundredths place is the same, thousandths place is where we can see the difference, okay? And because 7 is larger than 5, this decimal is larger. This 8, again, and then we have a 0 here, so you can kind of see. Okay, so that was number 1. Let's go to number 4. Okay, for this question, we're solving a system, right? And we're going to use something called substitution. A system is simply just 2 or more equations, and these are linear equations that if I were to graph them, they would make a line. And so the solution to a system is where those two lines cross, meaning that's where they share an ordered pair, or that ordered pair is the solution for both of them at the same time. And an ordered pair is an X and a Y, right? So I could graph these using my Desmos calculator, and I probably will do that to show you. But I can also graph this using something called substitution. So I'm going to start by using the graphing calculator. And the first thing I'm going to do is I'm going to graph this one, y equals 2x plus 1. Okay, so instead of using the Desmos regular calculator, I am going to use the Desmos graphing calculator. And I believe I said y equals 2x plus 1. Yes, I did. So we're going to graph this. We're going to say y equals 2x plus 1. So the y-intercept is 1, which we can see here. And then the slope is rise 2, run 1. Rise 2, run 1. Okay? So next I'm going to graph the other point that's here. And it is 3x, the other linear equation, 3x plus 2y equals 30. Now you'll notice that is not in slope-intercept form, but I can change that very easily. I can solve for y. So if I subtract 3x from both sides, I get 2y is equal to negative 3x plus 30. So it's getting close to mx plus b. I'm going to divide both sides by 2. Now notice I'm going to divide every term by 2. So I get y is equal to negative 3 halves x. And then what is 30 divided by 2? It's a positive 15. So this is the equation that I'm going to graph alongside of this one. So let's go ahead and plug that in. Negative 3 halves x plus 15. Y equals negative 3 halves x plus 15. So I'm going to have to move my graph a little bit here so I can see where they intersect. This has, if you look up here, a y-intercept of 15 and then a negative 3 halves slope. 1, 2, 3, 1, 2. So down 3 over 2. Down 3 over 2. Now, that point where these intersect is right here. And that point is 4, 9, right? That's where they intersect. I'm going to show you how we can get that algebraically without graphing, okay? We're going to use something called substitution. So here it's telling me what y is equal to. Well, here we have this second equation. If y is equal to this expression, we can put this expression in for y here. So I'm going to give you an example. 3x plus 2, and where there was a y, I'm going to put this whole expression in. And then I'm going to come back and I'm going to finish it as it's written. So then I'm just going to go through and I'm going to first distribute. So 3x plus 2 times 2 is 4x, and 2 times 1 is a positive 2 equals 30. Now I can combine some like terms. So I have a 3x and a 4x, which makes 7x plus 2 is equal to 30. We can use inverse operations and subtract 2 from both sides. So 7x is equal to 28. And divide by 7, x is equal to 4. Well, notice what we found when we graphed. X is equal to 4. Do you see the 4 right here? X is equal to 4. So we have part of our solution. Actually, it's over here. X is equal to 4. I might make that red so that you can see it better. That's part of our solution. But we're missing the y value. So what we're going to do is we're going to come back in and we need to use either one of these equations. And I'm just going to use the top one. It's probably a little easier to use. And if I know that x is 4, I can solve for y. So y equals 2. X is 4 plus 1. Y is equal to 2 times 4, which is 8, plus 1, which is 9. And we know that that is exactly what we got when we graphed. This is the point where those two lines intersect or where they share a solution. So what that means is 4 and 9 would go here and make that true. It would also go here and make that true. So let's test it. 3 times 4 is 12, plus 18 is 30. And here, 4 times 2 is 8 plus 1 equals 9. So it makes it true. So that ordered pair makes both of those equations true. And it's also where those two lines cross when we graph them. So my answer is 4, 9. Okay, let's do this one. We've got, let me change here. State the rate of change, slope, y-intercept, and initial value for both. First of all, initial is another word for beginning. Okay. And when we talk about a y-intercept, we know that's where it crosses the y-axis. The slope is the change in y over the change in x, right? It's the rise over the run. And rate of change is exactly the same thing as slope. Y-intercept is exactly the same thing as initial value. Okay, and I'm going to show you why that is. When we talk about initial value or y-intercept is what happens when x equals 0, right? So on a graph, when x equals 0, whatever the y is, so let's say 0, something would be my y-intercept, right? So let's start there. Let's start with the y-intercept of this table. Now, these are the x values at the top. These are the y values at the bottom. So another way to write that first point is 2, 18, 4, 14, 6, 10. When you see it in a table, it's kind of nice because you can see the relationships between each of these, okay? But is it easy to find the x value, right? So we want to know, what would y be when x is 0? Well, let's see what's happening here. We are adding 2 here. 2 plus 2 is 4. 4 plus 2 is 6. 6 plus 2 is 8. What are we doing here? 18 minus 4 is 14. 14 minus 4 is 10. 10 minus 4 is 6. So if I were to go and follow this pattern, 0 plus 2 is this, and something minus 4 is 18. So this equals what? 18, 19, 20, 21, 22. Is that 22? Yeah. So when x equals 0, y equals 22. So my y-intercept is going to be 22. Probably a nicer way to say that would be this. That'd be the way to notate it as an ordered pair, 0, 22. You could also say 22 since you're showing that it's the y-intercept. And the initial value is also 22 because that's where our graph begins. Remember, y equals mx plus b, and b is where we begin. Okay, so what is the rate of change? That is change in y over change in x. And then ours says every time our y goes down by 4, our x goes up by 2. So that's the same as negative 4 over 2. And that's the same as negative 2 when I simplify it, right? So my rate of change is negative 2. And if we want to do a rate, it's generally a ratio. So it would be negative 2 over 1. That's our rate of change. So that's saying every time my y changes by going down by 2, my x would go up by 1. So my slope in simplified form is just negative 2. Okay, so that gives you quite a few answers. This one is worth 4 points. Okay. The letter B for this is worth another 4 points. And I think you'll be able to get it now that I've shown you this one. This one is worth 2 points. And this one is worth 1, 2, 3, 4, 5, 6. So I've given you quite a few points here in this video. Hopefully this helps you. I hope you have a great day.